Today's lesson is on unit rates with fractions, which is topic 1.4. So please add the note sheet to your notebook when you are done and add the table of contents for page 14. So here's example 1 on the front of the note sheet, which is pre-done for you. So you'll notice the difference between a unit rate and the ratios we've been doing is the units will be different. In this one, we're going to be trying to find out miles per hour, miles per 1 hour. So we want to make the denominator a 1 hour. Therefore, we need to multiply by the reciprocal because any number multiplied by its reciprocal will equal 1. And then whatever we do to the denominator needs to happen to the numerator. And then we multiply across 4 times 1, 2 times 1. We get 4 over 2, which simplifies to 2. And this is miles per hour. So we would write it as 2 miles per hour or 2 mph for the abbreviation. Now down below it, we have what would happen if this was a ratio problem. Here we have yards squared and yards squared. This is the units used for area. So it looks like we're comparing two values of area. So the units have to match if it was a ratio problem. Because the units match, anything that divides by itself can be canceled out, so we don't need the units anymore in order to finish our ratio. The work will be the same. We want the denominator to become a 1, and if we simplify, we're going to get 2 over 1, and that is our ratio. So you'll notice the answers are different. We have 2 miles per hour, and we have a 2-to-1 ratio. So ratios and unit rates, same way to solve, but the answers are different in the case of units. So here's the one that's pre-done on the note sheet. Please make sure you highlight any key information. And I would like you to add in your own handwriting here that the answers are different. So we're on the inside top left of the note sheet. This time around, we're going to be finding out meters per minute. So we're going to be converting this into a unit rate. So we need 1/3 of a minute to become 1 minute. Therefore, we're going to multiply by the reciprocal. We need to change this number into improper because you can do it, but it's challenging to multiply a mixed number by a fraction. So it's better to change it into a fraction, an improper fraction, and then multiply by the same number that we use down here. Multiply across, and we get 9 over 2 meters. Now, 9 over 2, or 9/2 meters per minute, isn't very clear. So if somebody is like, how far is that? It's better to change it to a mixed number. So we change our unit rates into mixed numbers when needed because the value will make more sense. So changing 9/2 into a mixed number, it's 4.5 meters. So distance-wise, that makes sense. So 4.5 meters per minute. And then if this was a ratio problem, you're noticing we're comparing minutes to minutes in this case. This could be the amount of minutes it takes to, I don't know, it could be anything. I'm having a brain lapse on what these could mean, but it's a comparison of two things. So we've got the units canceling out because they're the same. The work will be the same. All of this work will be the same, just won't have any units. And the final answer is going to be a ratio, so a comparison of two values. So 9/2. So once again, very different answers in the sense of this one is a comparison of two numbers versus this one is 4.5 meters per minute. So here are the pre-done notes for you in color. Please add in something in your own handwriting about the fact that these answers are different, even though the numbers are equivalent. What they represent means something different. Okay, so example 3, I would like you to try this one, so you could pause the video before I click through. You will need to fill in the missing value though here of 1/2 an hour and 1/2 of a pizza. So technically this S shouldn't be here. So this one here is a word problem that it could represent, and we're going to find what is the unit rate for pizzas per hour. Well, we want to find out 1 hour. So if we have half an hour, to make half an hour become an hour, we're going to double it or use the reciprocal. 3¼ pizzas, we need to change that to improper in order to multiply, or you could think of doubling this. That might be easier. 3¼ plus 3¼ because we're doubling it. We're doubling this to become an hour. We're going to be doubling this, or you do the math this way and you get 26 over 4. Well, how many pizzas is that? That's why improper fractions don't make as much sense as a mixed number in this situation. So 4 goes into 26 6 times. We get 6 and 2/4, but we can simplify that. So that's 6.5. So if you double 3 1/4 pizzas, that's 6.5 pizzas per 1 hour. Down here, here's an example. Little Caesars makes 3 1/4 pizzas in a half an hour, and a gourmet restaurant makes half a pizza in a half an hour. So we're comparing the speed of making these pizzas. So the pizzas per half an hour is the same units, so the units will cancel out. The work will be the same once again, so we don't really need to re-show it. But the final answer is going to be 26/4, which will then simplify to a ratio of 13/2 as the final answer. So Little Caesars making quite a bit more pizzas than this gourmet restaurant um, per whatever the time may be. So a 13/2 ratio. Okay, top right is the first you try. You need to fill in the missing number, which is 5 workbooks. Mrs. Schreiber is bundling workbooks to recycle. She notices that 5 workbooks weigh 7/8 of a pound in all, and that the workbooks weigh the same amount. What is the unit rate for pounds per workbook? Please pause and try the problem before you see the answer. So first most common mistake is not doing the order right. This wants us to find pounds per one workbook. So we need pounds in the numerator and the number of workbooks in the denominator. So this will be 7/8/5. The 5 can be changed into 5/1. In order to get 5/1 to become one workbook, we're going to do times 1/5. Up here, we're going to do the same number, 7 times 1, 8 times 5. So we're going to get 7/40 of a pound per workbook. So 7/40, technically, I guess we shouldn't have the S here, of a pound per workbook. So very, very light. During your favorite show, there are 7 commercials in a quarter hour. So the first part, A, is saying what is the unit rate for commercials per hour? So we want to do commercials per hour. So please try it, pause the video, and then check. So commercials is 7, and per hour is 1/4. So it needs to be 7 commercials over 1/4 of an hour. We need 1/4 to become a 1. So we're going to multiply by 4/1. 7/1 times 4/1 is 28, or 28/1. And therefore, we're going to have 28 commercials per hour. Now, part B is what is the unit rate for hours per commercial? So you'll notice these two units have switched. Therefore, if you understand that these units have switched, so therefore the answer is going to flip, we can do the work, multiply by 1/7 times 1/7, and we'll get the opposite of this, the inverse. So 28/1 becomes 1/28 of an hour per commercial. Marcus was able to drive 36.5 miles with 1 3/4 gallons of gasoline. What is the unit rate for miles per gasoline? Please try this one before you watch the rest of this clip. So it wants miles per gallon. So we're going to put miles over the number of gallons. We need to change both of these into improper fractions. And then we are changing gallons into a 1. So we're multiplying by the reciprocal. Do the same to the numerator. Multiply across. I would recommend cross canceling here. 4 divided by 2. But on here I didn't. So at the end I'm going to have to simplify by 2. And you'll get 146/7. Now, how many miles is that? Improper doesn't make sense in this problem. Okay, so we are going to need to change 146/7 into a mixed number. Here's the math to change it to a mixed number. So you're going to get 20 6/7 of a mile of miles per gallon. 26/7 miles per gallon. Almost 21 miles per gallon. So these are on the back of the note sheet. So if you do these ones, you're going to want to tape your notes into the notebook so that you're not gluing these in. I'm going to go ahead and just click through the work. I'll pause the video and look at it if you're not sure where these answers came from. And please ask me in class if you're not sure how to do these problems. Monica is making cupcakes. The recipe calls for 3/4 cups of sugar to make 10 cupcakes. The unit rate for cups of sugar per cupcake is going to be 3/40 of a cup of sugar per cupcake. And then what is the unit rate for cupcakes per cup of sugar? So that's going to be the reciprocal of part A, the inverse. So you flip it, and we need to change it to a mixed number so it makes sense because 40 thirds cupcakes is how many cupcakes? So it would be 13 and a third cupcakes per 1 cup of sugar. A bicyclist rides 1/5 mile in 2/65 of an hour. What is the unit rate for miles per hour? So the answer to this one, if you do the math, is 6.5 miles per hour. How far would a bicyclist travel in 4 hours? Well, we multiply our 6.5, which is 13/2 as a improper fraction, times 4 hours, and we will get 26 miles. So that's how far the bicyclist can travel in 4 hours. And that is the end of the lesson.